Okay, this seems like a good time to go over some supplemental items that maybe could help you in the future. This is quiz 3, and so quiz 3 was very similar to test 1, and everything that we did for quiz 3 and for test 1 we could actually do in Excel. It's good to learn how to do those things by hand, but would you do those by hand in the future in the workforce? Probably not. These are data, I think, rating of a movie, and you're supposed to list the frequency, how many times each one of these occurs. And so to do this in Excel, you go, we could list them out 10, 9, and we list them from top to bottom, the highest to lowest, 10, 9, 8, etc. And then the formula for this is count if, and then parentheses, we get our range first, so from A1 to whatever it is, E5, and then a comma, whatever our criteria is. For the first one, obviously it's 10, in parentheses, enter. And so then we would just do that for each one, 9, 8, we're getting, again, that range, comma, the criteria, so 6, 5, so on and so forth. That's how you do the frequency for ungrouped data. For the grouped data, should you do these by 5s or 10s? Partially it's up to personal preference, although I do think that there's a stronger argument to be made for intervals of 5, because using our formula, which was the range divided by 10, because we're trying to get about 10 classes, I think the range is 124 to 69. That divided by 10 is 5.5. I may actually have that formula. Yeah, right there. 124 minus 69 divided by 10 gives us a 5.5. And so 5.5 is closer, obviously, to 5. And so if we make those class intervals by 5, we would start at the bottom. We would also, our lowest number is a 69. We probably don't want to start at a 69. We want to start at a convenient number. So 60, 65, those are good convenient numbers. 69 is not a very, what they would call a convenient number. So we start at 65, even though it's not one of the numbers, but 69 is. And what we'll do there is we would do each one of these classes. We would do each one of those classes, so 70 to 74, so on and so forth. We're going by 5s. Each one of these numbers, the first number is divisible by 5. That's one of the reasons it makes it a convenient number, and we would go up to that, the 124. Equals count ifs. So this time ifs, because we're going to have more than one criteria, because we're going to go from 120 to 124. We get our range first, and then our criteria. So yes, count ifs or range greater than or equal to 120, comma, our range again, comma, less than or equal to 124. And that gives us a 1. We would have to take this formula and do it each time for each one of those intervals. So for the next one, it is 115, 115 to 119. And then, yeah, we would just go through and do each one of those. Let me make sure we're doing it right. We'll copy this. And so 95 to 99 should be 7. 5, 99, 7, ta-da. So that's how you can do count ifs. The first one was count if. The second one was count ifs when you have more than one criteria. Okay, so this is we're doing the cumulative frequencies, the cumulative percentage, the proportions, all these. So yeah, we got our frequency, F, 4, 4, so on and so forth. The total is 200. We just divide each one of these numbers by that 200 to get what the frequency, percentage for that range. So from like 600 to 624, that is B7 divided by 200, so 37 divided by 200, our total, and it gives us about 19%. So you can almost see kind of a standard distribution in there. And so yeah, there's a lot of scores here in this middle area. So you would do that for each one, B12 divided by 200, so on and so forth. Or you could do it by the total, which would be, what is that, B12. You can, if you want, you can put those dollar signs in. So let's see, it's a B2 divided by 200, or yeah, you could put it as that total, the actual number there, which is a B13. So let's see, B13. You put that in, and what you could do if you want to drag it down, we've talked about this before, you can put a $sign in front of that B and in front of the 13, and it will keep that number constant. So we can move this down, and so it changed. So it changed the next one to B3, B4, B5, because we pulled it down like that, but it kept that B13 constant. These are the cumulative frequencies, so each one as we move up. So in the first one, it's 8. There's only 8 in the 475 to 499. There are 8 in the 500 to 524, and so this is just adding those up. The sum of B11 through B12, B10 through B12, so on and so forth, until we get all the way up to 200. And finally, this is the percentage proportion. It is the proportion. If we wanted the percentage, we'd take it times 100. But anyways, this is this number divided by that total. So we can again do the same thing. We can put $signs here to keep it constant, and then we can just move it down. Which is interesting because when I do that, I actually found out that there was a typo in there. So by just dividing it or summing it up, but not actually doing this, doing the formula to keep it constant like that, there was a slight error in there. So that may be one reason to keep them constant and not try to do each one individually, because you'll have typos. And then yes, each one of these is this number divided by our total. And so again, just bring it down like that, keeping that B12 constant. This one is our same thing. Instead of having that 200, we could put this one here, the B13, and $signs for each one, and drag it down. There you go. And if we wanted the percentage, again, we could put it out here and just take it, everything times 100. Okay, what is this? Mean, median, and mode is what it looks like. We have a data set here, and then we're going to get the mean, median, and mode. The mean is just the average, and we get that range, so equals average A1 through A15. The next one's the median, just like it sounds, MEDIAN, A1 through A15, and then the mode is MODE. So yeah, you get the mean, median, and mode just like that. These are our standard deviations. One's for a population, one's for a sample. In Excel, you have to differentiate between those two. So for a population, it's going to be stdev.p for population, and then you get your range in that parentheses. And for a sample, exact same thing. It's just instead of having a .p, you're going to have a .s, period S. These were z-scores, and I just typed in the numbers from the document, so it was like 490 minus 510 divided by 90. It's that simple. You just put it in exactly how it's listed. I usually will put things in parentheses to make sure, just to keep the operations in order. So you want to have the 2160 minus the 2190. To do that, put that in parentheses. If you don't, it's going to divide the 2190 by 55 first. And finally, we have, so you could do z-scores for a larger data set in Excel if you wanted to. I think it's easier in SPSS. It's just a couple of mouse clicks. But to do it in Excel, you get the mean and the standard deviation. So average equals average A1 through A20. The next one equals stdev.s A1 through A20. I went with a sample. If you were to do this in SPSS, it's always going to assume it's a sample, and so it might be best you just go with the sample in Excel as well. So you have the same numbers if you want to check them. We get our average, we get our standard deviation for the sample, and then it's just A1 in parentheses, A1 minus E1 divided by E2 minus our mean divided by our standard deviation. And then we can just take that and drag it down like that, and ta-da, we have all the z-scores. I guess I can clear it to show you for sure. Clear. So if we take that one and just drag it down, ta-da, we have all the z-scores. That's quiz 3. I have a couple other things to show you. Z-test, those were z-scores we were doing. We can do a z-test as well in Excel. It's not that difficult. So we have our sample mean, our population mean, our standard deviation, and our n. And so we would just take, this is the formula for it, A2, our mean, minus the population mean. I'd have those in parentheses. Then divided by, again in parentheses, C2, which was our standard deviation, divided by the square root of D2. And square root is SQRT, is how you get that. And then, ta-da, z-test, get a score of 3. Fairly easy. When we were talking about z-scores, one of the things I talked about was the idea that you can compare things that are different by using those standardized scores. And so, like, let's say you were doing college admissions and you have some people that took the ACT and some people that took the SAT. You can't compare them directly because they use a different scoring system, but we can change them into z-scores and compare those standardized scores to each other. So in this example, I've got ACT students, SAT students. These would be like essentially participant numbers. Then we have our scores. So ACT scores, SAT scores. You would need to know the average and the standard deviation to do this, and I did look it up. The SAT mean is about 1028 with a standard deviation of 300. The ACT mean is 21 with a standard deviation of 5. So for each one of these, we would get those z-scores for the ACT or the z-scores for the SAT. In this one, for the ACT, we are looking at B2 in parentheses minus our mean, which was at J3, the 21, divided by our standard deviation, which was 5. Again, use those dollar signs to keep those constant, and then you can just take that and pull it down to get the z-scores for everybody. And then the same thing with the SAT. We'll take that 1200 minus the 1028 divided by the standard deviation of 300 and pull it down. And so now, for example, let's see, a close one would be ACT of 29 is pretty close to somebody that got an ACT of 29 is fairly close to somebody that got an SAT of 1500. If we are curious who has the best score, best standardized score out of all of these, it is going to be that 33 on the ACT. If we're curious what the weakest score is, it looks like it's going to be that 24 on the ACT. So again, we could use this to compare ACT, SAT, GRE, whatever it is. We could compare those using these standardized scores. We just need the mean and the standard deviation. I have shown some stuff in our RStudio in class, but I did want to show them here too in this video for people. Maybe if I wasn't able to do it in class, I know there was some tech issues in at least one of the classrooms. So I was going to show you how I would do this. I'll use that example of the cards sent and the cards received that we did for the correlations and the regressions. You can read a CVS file if you had these variables in a document somewhere. In this case, though, it's like they're not that much, so I'll just enter them real quick. I just created the sent, card sent, the 571393, received, just a little arrow, C, 10, 12, 14, 18, 6. We now have those two variables, the sent and received. We need to create a data frame, sorry. Name it whatever you want to name it. Data.frame, and then I'm going to get both those variables sent and received. I can check to see if those variables are there by typing what I just named it. So I named it COREX for correlation example, and there, all the data points are there. Run the correlation, pretty easy. COR.test sent. Whoops. You got to keep it, if it's capital letter, small letter, small letter. If you mix it up, it won't work. And so there we go. We got our p-value. If you recall, it wasn't significant, but we did have a pretty high correlation at 0.8. We just didn't have enough of a sample size. I was trying to see if I would remember how to do that one without looking it up. I was very close. So to do the regression, let's say we want to do a regression. Some classes I've already gone over regression, some classes I have not yet, but the idea that we could predict cards received by the numbers of cards sent. We have the exact same data, and regression is for using a prediction. We're trying to predict one variable. We're not, with a correlation, we're saying there's a relationship, but with a regression, we're saying this one predicts the other variable. And so how we would do that is LMGAMES equals LM linear model sent received, and then whatever our data frame is, which in this example was COREX. That statement, that line of code right there, created the regression, and now we can look at the results by doing summary LMGAMES. And then we'll go over this more in the lecture, but I wanted to put these all together in the same video. Our P, you'll notice, is actually the same as it was with the correlation. We'll get an F statistic and our degrees of freedom. This is not going to be large enough to get meet our critical F value, and we also will get an R squared of 0.64, which is basically saying that 64% of the variance in cards received can be explained by cards sent. But we'll go over that in the if we have not gone over that in your class, we will go over it very soon. Okay, I hope that helps, and maybe some of that's useful, maybe some of it you can use in the future. Thank you for listening.